morning, my name is Jerome Danasco, your instructor for today. So, I will discuss my topic all about the equivalent statements. So, what is equivalent statements, by the way? Definition. Two expressions are logically equivalent provided that they have the same truth value for all possible combination of truth values for all variables appearing in the two expressions. In this case, we write x is equivalent to y and x is equivalent to y and say that x, and y are logically equivalent. Before we discuss or before we evaluate the truth table and how we get the statement equivalent, we must first discuss the logical operators, which is the most important in finding the truth value of variables. So, what is logical operator? So, logical operator or connective or mathematical statements is a word or combination of words that combines one or more mathematical statements to make a new mathematical statement. So, a compound statement is a statement that contains one or more operators because some operators are used so frequently in logic and mathematics. We give them names and use special symbols to represent them. So, these are the logical operators in truth values or in equivalent statements. First is the conjunction. The conjunction of the statements P, P, and QQ is the statement P, P, and QQ. And it is denoted by P, the symbol is inverted V, so that is is denoted by P and Q. So P and Q, the statement P and Q is true only when both P and P are true. So that is the disjunction of the statements. P and Q is the statements P or Q, and it is denoted by P. Its symbol is V. So P or Q and P or Q, the statement is P or Q implies P or Q is true when at least one of P or Q is true. So the negation of the statements P is the statements of or not P, and it is denoted by the symbol like this. So P negate P. The negation of P is true only when the P is false, and the negation of P is false when only P is true. So the last is implication or conditional. Is the statements of P then Q, and is denoted by P arrow sign Q then P. The statement is P then Q or P then Q is often read as P implies Q, and we have seen in section that P implies Q is false only when P is true and Q is false. So this is my example. Example number 1. So our given is not P then Q. So the statement is if I don't study then I fail. So the premises number 2 is P or Q, or the statement is I study or I fail. The problem is determine the truth values of the given statement. So this is how you construct a truth value of the given statement. So first P, then Q. The negation of P. So our table P true, false, false. Word Q is true, false, true, false. The negation P is false, false, true, true. And then the first premises, which is negation of P, then Q. That is our first premises. So negation of P, negation of P, then Q. So, false, true, it is true. Then false, false, since it is what you call this, implies. So if false or false, the answer is true. Then since true and true, the answer is false. And when the P is true, then the Q is false. So our answer is false. Then the second premises, which is P or Q. P or Q. So answer is true. True, and the answer is true. The answer is true. Then false, false. Our answer is false. So in the truth table shown here, the last two columns, so the last two columns have the same exact truth values. Therefore, the statement negation of P implies Q is logically equivalent to the statement of P or Q. And now for our second example. So construct a truth table for each statement below, then determine which two are logically equivalent. For our first statement is not Q implies P. So our first table, P, Q, negation of Q, negation of Q, then P. This is the first table. So true, false, false, then our Q is true, false, true, false. Negation of Q, so false, true, false, and true. So negation of Q implies P. So negation of Q implies P. So F and T, so our answer is true. So T and P, our answer is true. And false and false, our answer is true. Then since our Q is P, then our P is false. So the answer is false. Then, and to our second statement, which is negation of P implies Q. So since we have some examples of P and Q here, so we now solve for the P implies Q. So our P implies Q is true. True and false is false. And false and true, answer is true. And since false is false, our answer is true, rather true. True. This is false. True, false, true, false. So since we need to negate P implies Q, so our negation is reverse. So false, true, false, false. That is our second statement. This is our first statement. So our third statement is P or Q. So P and Q. So since P, true, true, false, and false, then true, false, true, false, and P or Q. So true and true, our answer is true. True and false, our answer is true. And false and true, our answer is true. Then since false is false, our answer is false. So the truth table shown here that negation of Q implies P is logically equivalent to the statement number 3, which is the P or Q. So we will place the truth values of these two equivalent statements side by side in the same truth table. We will then examine the biconditional of these statements. Now, I will construct a truth table for negation Q implies P biconditional, or Q is equivalent to P or Q. So, P, Q, then negation of Q, and negation of Q implies P, then negation, and P or Q. Let's continue. So solve for the P. So true, true, false, false, then Q is true, false, true, false. The negation of Q, so false, true, false, true. Then negation of Q implies P. Negation of Q implies P. So true, 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 and false. So P or Q, P or Q. So true, 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 and false. So our biconditional, let's look for our biconditional if it is a tautology. So negation of Q implies P, then biconditional implies P or Q. So since true and true, our answer is true. True and true, our answer is true. True and true, our answer is true. And false, our answer is true. So the statement is true. So our biconditional is a tautology. That's all for my topic about the equivalent statements, and once again, good morning and see you next meeting. Thank you.